Good day. Our lesson for today is on Bairstows method. So Bairstows method is applicable only for algebraic functions, while the first four methods we have discussed previously, the MOS, the ISM, the Newton-Raphson, and the half-interval method, is applicable for both algebraic and transcendental functions. Bairstows method employs synthetic division and can derive two roots at a time. It can derive both the real and imaginary roots, and the first four method is applicable only to equations with real roots. The basic purpose of the Bairstows method is to find the quadratic function of the polynomial function of x. So the purpose is we can derive or we can arrive to the function of x equals x squared minus ux plus v times the function q of x. So here are the steps using Bairstows method. First, we have to normalize the equation. When we say normalizing the equation, it means that the first term or the term with the highest power should be, or the coefficient should be equal to 1. Number 2, or step 2, is to select the initial values for u0 and v0. So the formula for u0 is equal to a1 divided by a2, or the coefficient of the term with the first degree over the coefficient of the term in the second degree. So v0 is the coefficient of the constant a0, or the term with a zero exponent, and divided by the coefficient of the second degree equation. The third step is to construct and complete the Bairstows table using the a's as the initial values of u and v, and we can solve for the b's. If b0 and b1 are not exactly 0, we will solve for the value of c. We will continue to solve for the value of c. From the obtained b's and c's, calculate the next increment for the next value of u and v. So we are to recompute for the value of delta u and delta v, that is equal to the determinant b0, b1, c2, c3 over c1, c2, c2, c3. The same with delta v, that is c1, c2, b0, b1 divided by c1, c2, c2, c3. We obtain the next value of u and v, or the next value of u is equal to u0 plus the change in u, or the delta u, and the next value of v is equal to v0 plus delta v. So we use the values of u and v to solve for the iteration. We repeat the steps 2 and 3 until the previous and the present, or the new value of u and v are the same. So we are to stop until such time that we reach the new and the previous values of u and v, or coefficient u and coefficient v is the same. So we substitute the value of the u and the v that we have derived using that synthetic division to this equation, and the remaining value will be the function of q of x. And then we solve for the root of the polynomial equation, this one. We can use factoring or the quadratic equation, negative b plus or minus square root of b squared minus 4ac all over 2a. So that is how to solve for the root of the polynomial equation. So to fully understand the Bairstows method, let us have this example. Consider the equation function of x equals 2x to the 5 minus 6x to the 4th minus 20x cubed plus 20x squared plus 88x plus 96. So let me place the slides here. So the first step is to normalize the equation. As I have mentioned earlier, when we say we normalize the equation, we will turn the first equation with the highest exponent into 1. So how do we make this the numerical coefficient of x to the 5 into 1? So how do we make 2x to the 5 into 1, the numerical coefficient? So we will divide the 2 by itself, or we will divide 2 by 2. So if we will divide 2 by 2, we will do the same all throughout the equation. So 2 divided by 2 is 1. So negative 6 divided by 2, that becomes negative 3. Negative 20 divided by 2, that is negative 10, plus 20 divided by 2, that becomes positive 10, positive 88 becomes plus 88, 96 divided by 2, that becomes 48. Now we have normalized the equation, or we have turned the first term of the equation with the highest degree into 1. Next is to solve for u0 and v0. Our formula for u0 is equal to a1 all over a2. As I have mentioned, a1 refers to the term with the first degree equation. So a1, so in the equation, the term in the first degree is 44, so that's why we have 44 here. And a2, the term with the second degree, that is 10, that's why we have 10 here. The 44 came from this one. So 44 divided by 10, that is equal to 4.4. On the other hand, our formula for v0 is a0 all over a2. That is the formula of the term with x equal to 0. So that is the term with the constant, that is 48, because that is 2, 1, and 0 here, x to the 0. But x to the 0 equals 1, so we do not tend to write the term x raised to 0 here. So 48, the constant, that is here, divided by a2, again, the term with the second degree, because 2, second degree exponent is 10, so that is 10, that is equal to 4.8. So the value of our U0 is equal to 4.4 and the value of our V0 is equal to 4.8. Now let's go to the next slide. We are now asked to construct the Bairstows table. Again, as I have mentioned earlier, the Bairstows method employs synthetic division. So, the terms here at the upper right, on the upper portion of the table, the one in red, just denotes the term, or it is just a legend that this term is x equals 0. This term equals x raised to 1. This is x raised to 2, x raised to 3, x raised to 4, and this is x raised to 5. That is what is denoted by these numbers in red here. So from the equation, what is our function of x? That is function of x is equal to, let me move this a little bit here. So let us solve here. Function of x equals x to the 5 minus 3x to the 4th minus minus 10x cubed plus 10x squared plus 44x plus 48 equals 0. Now, again, 1 denotes to this coefficient, negative 3 denotes to this coefficient, this one, and so on. Then we will proceed with synthetic division. So by the way, before we proceed with synthetic division, so we need to involve the values of the U0 and the V0 that we have derived previously. Our U0 is 4.4 and our V0 is 4.8. The U0 and the V0 is the one that we place here as the dividend. So, but why is it that the sign here is negative, whereas the values we have derived from U0 and V0 is positive? So remember that, for example, in solving for the roots, when we have, say, x minus 5 equals 0, the root will be x equals to 5. So that's why the value of the root is, when transposed, it becomes the opposite of the value derived when used as a divisor. So the values here of your u and v are always in the initial value is the opposite of the value derived from the U0 and the V0. So let's now proceed with the synthetic division. So we normalize the equation for us to easily do the synthetic division. So the first step is to bring down 1, and then we multiply this 1 by 4.4, negative 4.4. So that becomes negative 4.4. And then in synthetic division, what do we do with this one? We add the next term and the answer, that becomes negative 3 plus 4.4, that is 7.4. Next, the 7.4 again will be multiplied to negative 4.4, so negative plus negative, that becomes positive, so that is 32.56. But this time, the synthetic division for the V will only start after the first term, or the first synthetic division for U has been achieved. So it is quite delayed by one process. The synthetic division for V0 is delayed for at least one process compared to the U. So here, the multiplication of 1 by 4.8 will only start from this term here. So 1 times 4.8, that is negative 4.8, that is negative 4.8. And then we sum up this one. So negative 10 plus positive 32.56 plus negative 4.8, that is 17.76. Next, 17.76 times 4.4, negative 4.4, that becomes negative 78.144. But this time, the V value will only have negative 7.4, since it is delayed one step, times 4.8, that becomes positive 35.52. And then again, we add, that is negative 32.624. Negative 32.624 times negative 4.4, that is positive 143.5456. Then it is delayed, so we will be getting the value here, 17.76 times 4.8, that is negative 85.248. We add 44 plus 143 plus negative 85, that will give you 102.2976. Then negative 102.2976 times negative 4.4, that will give you negative 450.109. Again, delayed by 1, so 32.624 times 4.8, that will give you 156.5952. That will give you, add 48 plus negative 450.109 plus 156, That will give you negative 245.514. So it is mentioned here that if your B is not equal to 0, you have to continue the synthetic division up to C. We have to continue solving for the synthetic division because the value we have derived here is not equal to 0. So we will continue the synthetic division. So we just copy again our 4.4 here, the value of U0 and V0, which is negative 4.8, and we will again recompute or continue the synthetic division. So we have to bring down 1 times negative 4.4, that is minus 4.4. We add this one, that is negative 11.18. And then negative 11.18 times 4.4, that is 51.92. But again, it will be only from this time that we will start, since it is one process delayed, the V, the multiplication of V. So 1 times 4.8, so it becomes minus 4.8. So then we will add this one. So the answer is 64.88. And we do the process again, 64.88 times 4.4, that is negative 285.472. Again, delayed by 1, so negative 11.8 times 4.8, that is 56.64. And then we add again these three. The answer is this one. Negative 261.496 times negative 4.4, that is 1150.406. Delayed by 1, so 64.88 times minus 4.8, that will give you negative 311.484. Then we add this one to give you this one. We do the same, but you will notice your C is still not equal to 0. So since it is not equal to 0, we will be continuing our synthetic division by getting U1 and V1. But what is the value of U1 plus V1? That is U0 plus delta V, delta U. And to solve for V1, that is V0 plus delta V. That's why we need to solve first the value of delta U and delta V. So what is the formula for delta U and delta V? So it is given this one. So what is the value of B0, B1, C2, and C3? So going back here, what is the value of B0? So again, this is the B's. These are the B's. This one are the B's. This is B0. This is B1. This is B2. This is B3. This is, so let me erase this first. Let me clean this one so that it could be visible to you. So here, this one is, since that is for the x0, so this will be also equal to, this one is for b0, this one b0. This is b0, this is b1, this is b2, this is b3, this is b4, and this is b5. The same time, this one is for c0, this is for z1, this is c2, c3, c4, and this one is c5. So the formula is b0, b1. So what is the value of b0? b0 is negative 245 and b1 is 102.292679. So b1 is negative 245 and the b0 is negative 245 and the b1 is here. c2, c3. c2 is this one and c3 is this one. So that is these are the values. Over c1, c2, c2, c3. Just look at the values that you obtain using the synthetic division. So, how do we compute? We do the determinants. So we multiply this one minus this one. So b0 times c3 minus b1 times c2, and then so that would be equal to, let me just solve for delta u is equal to negative 245.514 times 64.88 minus 102.2976 times negative 261.456 divided by, again, we multiply this one minus this one. So that is 941.28 times 64.88 minus parentheses negative 261.456 times negative 261.456. Supposedly, if you solve this, you will arrive at negative 1.48407. So you do the same with delta V. So delta V would be equal to parentheses 941.28 times 102.2976 minus negative 261.456 times negative 245.514 divided by, so this is this one minus this one, again this one minus this one. So divided by 941.28 times 64.88 minus upper negative 261.456 times negative 261.456. If we solve this, we will get negative 4.40383. So that is how you solve for your delta U and delta V. That is how we arrived at these values here. So these values here. So after obtaining the du or the delta U and the delta V, we solve for the next value of U1 and V1 using the formula U0 plus delta U. So 4.4 plus negative 1.48 and 4.8 plus negative 4.40. So the answer is this one. So these values of U1 and V1 will be used in the next synthetic division. So if you will notice again, the values here are now opposite the value or the opposite the sign of the one we have derived here, as I have mentioned earlier in the first synthetic division process. So we will again perform the synthetic division. So we first solve for the B's. To solve for the B's, again, so take note here that the A's here is constant. It doesn't change. It still follows the A's of the coefficient of the original equation. So we bring down 1 times negative 2.91593, that is negative 2.193. Then we add this one, it is equal to this one. Then 5.91593 times this one, that is positive 17. And then again, the multiplication for V1 will only start here because it is again delayed by one process. So 1 times negative 0.39617, so negative 0.3917, and then we add, and the answer is positive 6. So we do that until we reach the synthetic division until we reach the last term. And again, since our B is not equal to 0, we will again continue to solve for the C. So to solve for the C, again, we use the synthetic division. 1 times 2.9193, so this is the answer. We add again this one, that is this one. The answer is this one. Again, until we reach the value of C. And then after doing that, you again need to solve for the delta U. If you will notice here, the du here refers to our delta U and the dv here refers to our delta V. You need again to solve for the delta U and the delta V using this formula. We will be using again the same formula, But this time, the value of your B0, B1, B0, B1, C2, C3 will be coming from this one. So the new synthetic division answers. So now the values will be coming from here. This will now be again your B0, this will be your B1, this will be your B2, this will be your B3, this will be your B4, and this will be your B5. And this one will be your C0, this will be your C1, this will be your C2, C3, C4, and C5. And then you again, so supposed to be this one will be now the U2 and the U3. You solve for, again, after getting the delta U and the delta V, you solve for the U2 and the U3, which is equal to U1 plus delta U, V2, I mean. And V2 is equal to V1 plus delta V. So it is quite a tedious process because you need to repeat the synthetic division until such time that your previous and your present value of U and V are the same. Again, you will only stop the synthetic division until your previous and your next value of U and V are the same. As you can see, in the iteration number 9, our U is equal to 1, and here V is equal to 6. In iteration 10, the U is also equal to -1, and V is equal to -6. So we stop the synthetic division. So we have stopped the synthetic division. However, we have not yet simplified the equation. So we stop until the new and the previous U and V are the same. And then earlier we have said that the values of U and V will be replaced to this equation. The values of U and V will be replaced to this equation times the function of Q of X. So the value of U is equal to -1 and V is -6. So that's why the equation here is x squared minus x minus 6. But how did we get this one? Where did we get this Q of X? So going back to the previous or to the last iteration, the value of the Q of X was derived here on the last value of B's that you have derived. These are the B. So here we have, so we have neglected this one. So we have assumed that this one will be 0 and this one will be also 0 because the exponent is very, very small. So this one becomes x raised to 0, this one becomes x raised to 1, this one becomes x raised to 2, and this one becomes x raised to 3. Because we have assumed that these values here are almost equal to 0. So that is 8.37, or if you will put that in decimal form, it will be equal to 0.000000. It will be 10 zeros, or it could be 9 zeros and 8. So that is almost equal to zeros. That's why these terms here, we have assumed to be 0. So this one will now become your x0, the last term. This now will become your x raised to 1. This term here will become your x raised to 2. And this one will become x raised to 3. So this is where this equation came from. So this one, we could easily get the roots of this one by, of course, using factoring lang. So, or maybe the synthetic division, the factors are x equals 3 and x equals negative 2. Or simply, you can factor x minus 3, x plus 2. That will give you x equals 3 and x equals negative 2 for this term. Or you can use the synthetic division, x equals negative u plus or minus u squared minus 4 ac all over 2a, but take note that our a is just equal to 1, so that's why it is not already included in the equation, because here we have seen that a is just equal to 1. Now, how do we find the roots of this equation, of the remaining q of x? So we have easily solved for the roots of x squared minus x minus 6, or the values of x for the equation x squared minus x minus 6. But how about for the q of x, which is x cubed minus 2x squared minus 6x minus 8? So how have we arrived from these roots? So same process still applies for finding the roots of x cubed minus 2x squared minus 6x minus 8, or getting the values of x for the equation x cubed minus 2x minus 6x minus 8. So we will still be using the synthetic division. So we will place here the coefficient 1, negative 2, negative 6, and we have here negative 8. But the problem is, what will be, or what shall be used as a divisor for the equation? So one of the easiest way to determine the divisor is to look at the value of our constant. So the constant here is 8. What are the factors of 8? It could be 2, 4, 8, or 1. So those are factors of 8. So we will try 2. Say for example, what if we will use 2? We will apply the synthetic division. 1, bring down 1. Then 1 times 2 is positive 2. We add this one, negative 2 plus 2 is 0 times 2, that comes 0. We add this one, this is negative 6 times 2, that is negative 12. And negative 8 plus negative 12 is negative 20. So we can already erase that 2 is not a root, because the last value derived is not equal to 0. So we can only assume or say that the divisor that we used is equal to is the a root or the value of x if the last value is 0. So let's try. How about let's try 4. So 1, -2, -6, and -8. This time we will try 4. If we will be using 4, so 1 times 4 is positive 4, -2 plus 4, that is positive 2, times 4, that is positive 8, -6 plus 8, that is positive 2, and 2 times 4 is positive 8, and -8 plus 8, that is 0. So therefore, 4 is a factor of x cubed minus 2x squared minus 6x minus 8. So the equation, the remaining equation will be, or the simplified equation will be x minus 4. Again, as I have said, if you are using positive here, when you translate it into equation, it becomes negative times. What is the remaining equation here? This time, this will become our x0. This is now our x1, and this will now be our x2. So the equation will be x squared plus 2x plus 2. Because after getting or factoring out the 4, this one remained in the equation. Now it is very easy to get the value of x or the root of the root of this equation using synthetic division. So if we will be using synthetic division for x squared minus 2x, so we have x squared plus 2x plus 2. The synthetic division is equal to negative b plus or minus square root of b squared minus 4 ac all over 2a. So x will be negative 2 plus or minus square root of, that is 2 squared minus 4 times 1 times 2 all over 2 times 1. So the roots will be negative 2 plus or minus square root of 4 squared is 4 minus 8 all over 2. Or this is equal to negative 2 plus or minus square root of negative 4 all over 2. But we still can rewrite this one into negative 2 plus or minus square root of, that is equal to 4 times negative 1 all over 2. But we all know that square root of negative 1 is equal to I. So we can simplify negative 2 plus or minus square root of 4 is 2 times I all over 2. So this is the value of x. So we can take x1 is equal to negative 2 plus, this is taking the positive 2i all over 2, that becomes negative 1 plus I, and taking the negative, that is x2, that is negative 2 minus 2I all over 2. The x2 is negative 1 minus I. So that's why the roots of the equation here are negative 1 plus I, negative 1 minus I, and the other one is x equals 4, which was derived from this equation. So in solving for the roots using Bairstows method, we need to review some of our knowledge in uh, algebra, especially in factoring or in taking the roots of cubic or quartic equation. So that is all, and thank you for listening. Now, now, how do we find the roots of this equation of the remaining q of x? So we have easily solved for the roots of x squared minus x minus 6, or the values of x for the equation x squared minus x minus 6. But how about for the q of x, which is x cubed minus 2x squared minus 6x minus 8? So how have we arrived from these roots? So same process still applies for finding the roots of x cubed minus 2x squared minus 6x minus 8, or getting the values of x for the equation x cubed minus 2x minus 6x minus 8. So we will still be using the uh, synthetic division. So we will place here the coefficient 1, negative 2, negative 6, and we have here negative 8. But the problem is, what will be, or what shall be used as a divisor for the equation? So one of the easiest way to determine the divisor is to look at the value of our constant. So the constant here is 8. What are the factors of 8? It could be 2, 4, 8, or 1. So those are factors of 8. So we will try 2. Say for example, what if we will use 2? We will apply the synthetic division. 1, bring down 1. Then 1 times 2 is positive 2. We add this one, negative 2 plus 2 is 0 times 2, that comes 0. We add this one, this is negative 6 times 2, that is negative 12. And negative 8 plus negative 12 is negative 20. So we can already erase that 2 is not a root, because the last value derived is not equal to 0. So we can only assume or say that the divisor that we used is equal to is a root, or the value of x, if the last value is 0. So let's try. How about let's try 4. So 1, negative 2, negative 6, and negative 8. This time we will try 4. If we will be using 4, so 1 times 4 is positive 4, negative 2 plus 4, that is positive 2, times 4, that is positive 8, negative 6 plus 8, that is positive 2, and 2 times 4 is positive 8, and negative 8 plus 8, that is 0. So therefore, 4 is a factor of x cubed minus 2x squared minus 6x minus 8. So the equation, the remaining equation will be, or the simplified equation will be x minus 4. Again, as I have said, if you are using positive here, when you translate it into equation, it becomes negative, times, what is the remaining equation here? This time, this will become our x0. This is now our x1, and this will now be our x2. So the equation will be x squared plus 2x plus 2, because after getting or factoring out the 4, this one remained in the equation. Now it is very easy to get the value of x, or the root of the root of this equation, using synthetic division. So if we will be using synthetic division for x squared minus 2x, so we will x squared plus 2x plus 2. The synthetic division is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So x will be negative 2 plus or minus square root of, that is 2 squared minus 4 times 1 times 2 all over 2 times 1. So the roots will be negative 2 plus or minus square root of 4 squared is 4 minus 8 all over 2. Or this is equal to negative 2 plus or minus square root of negative 4 all over 2. But we still can rewrite this one into negative 2 plus or minus square root of, that is equal to 4 times negative 1 all over 2. But we all know that square root of negative 1 is equal to I. So we can simplify negative 2 plus or minus square root of 4 is 2 times I all over 2. So this is the value of x. So we can take x1 is equal to negative 2 plus, this is taking the positive 2i all over 2, that becomes negative 1 plus I, and taking the negative, that is x2, that is negative 2 minus 2i all over 2, the x2 is negative 1 minus I. So that's why the roots of the equation here are negative 1 plus I, negative 1 minus I, and the other one is x equals 4, which was derived from this equation. So in solving for the roots using Bairstows method, we need to review some of our knowledge in algebra, especially in factoring or in taking the roots of cubic or quartic equation. So that is all, and thank you for listening.